The problem isn't that AI makes mistakes. It's that it sounds exactly as sure when it's wrong as when it's right. Think about how you actually decide to trust an answer from a chatbot. Fluent, detailed, no hedging feels reliable. Careful and qualified feels shaky. We read tone as evidence because that is how we have always read people. Here is the uncomfortable part. The model generates that confident tone the same way whether the answer is right or wrong. The certainty you hear is part of the text. It is not a property of the knowledge behind it. Researchers measure this with something called calibration. Ask the model for its confidence. Check the answer. Do that many times, then plot confidence against accuracy. A model that is right 90% of the time when it says 90% sits on a perfect diagonal line. That plot is called a reliability diagram, and it is built in 4 moves. Collect many answers. Group them by how confident the model claimed to be. Measure the real accuracy inside each group. Then compare the curve you get to the diagonal. The distance between them is the calibration gap, and here is where the story turns. Pre-training, just predicting text, produces models whose probabilities are surprisingly honest. Then comes the tuning that makes a chatbot pleasant and agreeable. Measure again after that step, and the curve has bent away from the diagonal. This is not a rumor about someone else's model. OpenAI's own GPT-4 report says the pre-trained model is highly calibrated, and that the post-training hurts calibration significantly. Their words, their plot, and the pattern is older than chatbots. Back in 2017, researchers found that modern neural networks were worse calibrated than the ones from the 90s. Accuracy rising, honesty about uncertainty falling. Why would a model guess instead of admitting it does not know? Because we grade them that way. Benchmarks score right or wrong with no credit for saying I am not sure. Recent work argues models hallucinate because training rewards guessing over acknowledging uncertainty. One honest boundary. These results come from specific models on specific benchmarks, and your domain may differ. And calibration does not make a model right. A perfectly calibrated model can still be wrong a third of the time. It just tells you so. So here is the shift. Before, the model's confident tone tells me how likely it is to be right. After, confidence and accuracy are 2 separate dials, and the gap between them is a curve you can measure. Try it yourself this week. 1 domain, 10 answers. Ask for a confidence score each time, then check them. That little table is your own calibration curve. Trust the curve, not the tone. Where would you measure first?